Today we're going to talk about triangle midsegment theorem. And before we get to the midsegment theorem, let's just talk about what the midsegment of a triangle is. So first of all, I know it says example here, but our midsegment is here. It goes from here to here, which is segment DE. And what a midsegment does, the midsegment of a triangle, is it connects the midpoints of two sides of the triangle. So as you can take a look here then, is what happens is, since these are midpoints, this length of BD and AD have the same length, and BE and CE also have the same length. So that's a little bit helpful down here when we look at the actual triangle midsegment theorem. And what it says is, if a segment joins the midpoints of two sides of the triangle, then the segment is parallel to the third side, and it is half as long. So if we go back and look at this, so now we can say, so using the diagram above, if DE is a midsegment of ABC, then DE is going to be parallel to AC. And what we can also say is that the measure of DE is 1/2 the measure of AC. I think I need a segment here. So again, this blue segment, DE, is half as big as the orange segment. So let's take a look here at an example. It says identify all pairs of parallel segments, and what we can start with here is, I started with WY. So WY, segment WY, is parallel to QY. And let me change colors here so we can distinguish. But we also could have done XW is parallel to RS. But we have a third statement that we can make, and that is XY is parallel to QS. So now that you've seen that one, it'll probably make problem number 2 a little bit more straightforward, because identify all pairs of parallel segments again. Well, let's go back and use our colors, and it doesn't matter which order you start in, but you do want to list all 3 of them. I will start with JK. Segment JK is parallel to segment FH. We can also say that segment JL is parallel to GH. And finally, we can take segment KL and it is parallel to segment GF.